So for this problem, you're trying to find the integral from 0 to 4 of 1 over the square root of 16 minus x squared dx. So for this, it would be helpful to use sign substitution. So let's say that we let x equal something times the sine of theta, and we want to make this integral into the form, the integral of 1 over square root of 1 minus x squared, and it can be times some constant k, because this right here is the antiderivative of sine of x. So to do so, we're going to let x equal 4 sine theta, because then this will become the integral of 1 over the square root of 16 minus 4 sine theta squared, which will later become the square root of 16, 1 minus sine squared theta. And you can pull out that 16 as a 4, so it'll be 1/4, 1 minus sine squared theta. So when you substitute 4 sine theta in for x, you also have to change the dx into a d theta. So if we take the derivative of both sides, dx equals 4 cosine theta d theta. So if we put that in, we would have 4 cosine theta d theta. So that 4 can also come up out here. So once we reach this point, we can use the identity that cosine squared theta plus sine squared theta equals 1. So cosine squared theta equals 1 minus sine squared theta. So we can take this 1 minus sine squared theta and plug in cosine squared theta. So this becomes the integral of cosine theta over the square root of cosine squared theta d theta, which is just the integral of cosine theta over cosine theta d theta, which is pretty much just the integral of 1 d theta. So one thing that we haven't yet addressed is the limits of integration. So since these were for x values, but we need it for theta values now, so we had x equaling 4 sine theta. So when x equals 0, we have 0 equals 4 sine theta. So theta equals arc sine of 0, which equals 0. And when x equals 4, you have 4 equals 4 sine theta. So 1 equals sine theta. Theta equals arc sine of 1, which equals pi over 2. So now that we have the limits of integration, we can just evaluate this integral. So this becomes theta evaluated from 0 to pi over 2, which just is pi over 2 minus 0. So your answer to this is pi over 2. Oops, pi over 2.